Now you must be aware that ASA can be deployed in two types, like that is called ASA deployment type. ASA appliance can run in two modes, that is routed mode. All these months, like when we started the lecture and after we started ASA firewall, this ASA was working in routed mode. Okay, that is layer 3 mode, layer 3 firewall mode, where forwarding of traffic is purely based on the IP address. That is why you see when I show you the diagram, let me share the screen. One minute. This is the new transparent firewall diagram that I'm sharing, but you remember that we did this diagram and by default all the firewalls were in routed mode. Okay, so ASA by default was in routed mode, and we tried to, and we did lot of uh, exercise on this. Okay, you attended all of my lectures and at least you saw the videos also. Now there is something change in the mode that we are going to discuss today, and that change of mode, that is the second type of mode that we are going to see today, is called transparent mode. Now you people have already done routing and switching, so you must be aware about the layers, OSI layers. You know that we have layer 1, then we have layer 2, then we have layer 3, layer 4, layer 5, layer 6, and layer 7. OSI 7 layers. So layer 1 is physical layer, layer 2 is definitely data link layer, layer 3 is network layer, layer 4 is transport layer. Okay, like that application, presentation, and session is also there. So here there is a difference between the layer, because in routed mode my router, my firewall is purely working, or you can say firewall is also working like a router. You already know how router works. Like router always do routing. Router works, okay, by maintaining a routing table. Router always do a forwarding decision purely based on the routing lookup. He always, whenever he receives the packet, you always go into the routing table to find out what is the ingress of the packet, that is how the packet has arrived on which interface, and how I have to egress that packet, that means how I have to exit that packet out of the router. So router working is definitely, router by default works in router mode. You can disable routing in routers also, like for making a router as a host, I always say no IP routing. So when I say no IP routing, you see the table is disabled and now he act as a host. So same way, my firewall can also act definitely by default in routed mode, which is layer 3 mode, where you see I have given all the interfaces like E0, E1, E2, or gigabit 0 by 0, gigabit 0 by 1, gigabit 0 by 2, or like failover link interface, or you can say stateful failover link. All those interfaces carry an IP address, because see, if your device is working in layer 3, he 100% needs an IP address, a software address. It can be an IPv4 address, it can be an IPv6 address, and definitely that interface has to be done no shut to bring it up. So first thing is, what is routed mode? So you know from the router that how this router works. The second mode is transparent mode. So my firewall definitely works in routed mode by default, but now I will change this mode from routed mode to transparent mode. Transparent mode means like much similar like a switch, L2 switch. You know how is the working of a switch. He receives the frame. What is the function of a switch? Address learning, forwarding, filtering decision, loop avoidance. These are the functions of a switch. Switches works on layer 2, that is data link layer. Switches maintains the MAC table, that is called CAM table, also sometimes hardware address, that is hexadecimal address. They do single broadcast. They have single broadcast domain, and they have multiple collision domain. In order to avoid loop, they use spanning tree protocol. So this is the speciality of a switch, that is layer 2. Now, why there is a reason? What is the reason why you are making this firewall as a layer 2? Why you want him to run in the layer 2 mode? So many times you see the setup is ready. The reason, I'm telling you the reason. Many times the setup is ready. Like initially what happened, the company is interested first in routers and switches, that means setting up of LAN. So when a company is interested in setting up of LAN, they always go for switches, they always go for PC, they always go for, you know, printers, they always go for a lot of LAN setup, access points, wireless LAN controllers. So way back, hello. So way back, if you see, firewall was not that popular in the industry. Firewall comes later on. Like once the setup is done, firewall comes in picture. Everybody do the same thing. They will never purchase the firewall first. They'll always purchase firewall later on. So suppose a company is managing its network without a firewall, you can go on without a firewall also. Initially they think like that, they can go on, and nothing, nobody is going to stop them if they decides that no, we don't want firewall. Like I think I don't need you know any kind of safety, like while driving scooter I don't want helmet. I think I don't need it. But one day what happened, i I get dashed by someone and I fell down and I got hurt. Okay, and doctor is, when somebody took me to doctor is telling you go, you are saved this time because you don't got, or you didn't got that much hurt. But if the accident was like fatal, you could have died because of your head injuries. And you see many cases of death in accidents are because of head injuries. So the rule or the government or the traffic police always guide you that you should always wear helmet, man. It is not for maintaining the law, it is for your own safety. But okay, man, I say okay, I don't want it, so it's okay, nobody can force you, no. Only if traffic police sees you without helmet, he can catch me, he can fine me, otherwise no. So same way, if firewall is not implemented in the network, nobody is going to fine these companies, okay, why you are not implementing firewall. So initially what happened, they have their own setup where you can see the machines are carrying an IP address of 192.168.10.2.3 whatever, and the setup is ready. Okay, now if the setup is ready and then they don't want this setup to get disturbed, but suddenly after some time they notice that there are a lot of attacks coming in, lot of application attacks, lot of viruses, lot of worms. So now the company is thinking of implementing firewall. So yes, they can implement the firewall. Now they have one condition. They are telling boss, we don't want to disturb this network. Already router is acting like a gateway who's having an IP address of 192.168.10.1. Machines are 10.2, 10.3. So we don't want to disturb this. But at the same time, we want to set up, we want this traffic between the inside users or servers should get filtered through a firewall. So can you do that? Yes, there is an option available which can do that. What is that option available? Making this firewall works in transparent mode. What is the advantage if you insert a firewall? Like if you want to insert a switch here in between, you can do it because it's a layer 2. So many times the term is transparent bridging. Okay, you have a barrier. I always say like that. You have a barrier, but that barrier is not made up of like concrete barrier. It is a barrier of a glass. That means it is see-through. It is transparent. Barrier is there, protection is there, but it is see-through. That means the layer 3 part is still not disturbed when you convert your box into transparent mode. That means you don't have to change the gateway of these machines. You don't have to change the IP address of this router. They can work as it is, and you can insert your firewall and make it work in transparent mode. So try to understand there are two firewall modes, or you can say deployment type. One is routed mode, that is works my firewall works in layer 3, and the second one is transparent mode, that is layer 2 firewall, where the forwarding of traffic is purely based on MAC addresses. Because see, my interfaces are now in a routed in a transparent mode. They are in switch mode, you can say. They are in access mode. So they are not going to accept any IP addresses. So if they are not going to access any IP address, they are working like a layer 2 port. I can't give IP addresses. But yes, they made provision in switches also. Like if you how you're going to manage this switch, how you're going to you know take care of the management plane of this particular device. So you can give an IP address to the switch, and you must be aware that we normally give interface VLAN 1 IP address so and so in order to manage a switch via telnet or SSH or via HTTPS. We always give IP address to interface VLAN 1. Definitely, if you're creating multiple VLANs, you can also create SVI, but SVI again is created in layer 3 switch when you convert your switch into routing. So initially, if you want to manage a switch, we always give IP address to, that is management IP. It's not a IP for routing. So same way, in ASA also, we normally give IP address to ASA for managing the ASA. That is, one IP address is allowed for managing that firewall from LAN or from wherever you want if the reachability is there. All routing decisions are done by the neighboring routers and hosts. So if you see my design, routing decision will be taken care by R1, R2. ASA has to just receive the packet from inside and give it to outside, receive the packet from outside and give it to inside. So at layer 2, an ASA's transparent firewall mode, it appears to operate as a layer 2 device without becoming a router hop or a gateway. That means earlier you see, if you remember, my inside IP address was 192.168.10.1. That means he was purely acting like a gateway for all those LAN devices. But now all the routing part will be taken care by router, because then the gateway will be router and not the firewalls. They can't see firewall. They will be filtered, but they can't see firewall. So if you have if you have a door of glass, many times you see people get dash because they can't find out there is a glass door. If it is very clean, you will not come to know. By mistake, you might dash also. They should put some sign on that glass door so that at least come to know that this is a glass door. Otherwise, people might dash it. You can't find out there is a glass door, but there is a door. So in transparent firewall mode, such it appears to operate as a layer 2 device without becoming a router hop or a gateway to its connected network. This is also known as layer 2 firewall, or there is one more name called stealth firewall, because the ASA interfaces have no assigned IP addresses and cannot be detected or manipulated. Now this is also one of the important features. Like many times people ask why you have to convert your firewall into transparent mode when it is already happy, or we are happy in routed. So no doubt, if you are happy in routed mode, you continue. If there is a requirement that you don't want to disturb your network, existing network, and you still want to insert a firewall in between the running network, you can go with a transparent mode. Second advantage you're going to get is what? Interfaces don't carry any IP addresses except for management interfaces. So your firewall is also protected from any kind of attack. That means nobody can manipulate, because you see, nobody try to attack on switches unless you have a disgruntled employees. I told you in my beginning theory lectures, disgruntled employees are everywhere. Every company you will find. In fact, you guys also must not be happy with the company's behavior. You also must be thinking of changing your company, because in this COVID situation, they are not giving you increment, they are not giving you salary on time. In fact, they are telling you if you are not good at your work, you get out, get lost. So you are worried with your job, and you are having a grudge also with your company. It is very rare that an employee is very much happy with its company. The satisfaction level of the employee is always down, because he is not getting paid well. According to him, he is not getting paid well. What he thinks is he is always getting underestimated by the company, so he is always disgruntled, never gets satisfied. In fact, you will not believe, my kids also sometimes tells me, you don't love us, you don't fulfill our wishes, after doing such a lot of things. So parents also lack lot of things, giving birth, giving them food, giving them good clothes, good education, everything. Our parents also gave us, but still there is always some complaints. You are not giving me PlayStation. So there is some kind of, you know complaints are there with the kids also. So they are kids. Forget about, we are talking about what you call, we are talking about employees. They are always worried. They are always worried for their job. They are not being paid. So disgruntled employees can only attack the switches or layer 2 devices. Otherwise, it is very rare or very difficult to attack a switch from outside, that is from internet. Very rare. So you are getting a chance, okay, you are getting a chance that your layer 2 firewall or a stealth firewall will not be compromised by anyone, because it is not at all carrying any IP address and it cannot be detected or manipulated until unless he gets the access to the management. But management is only a single management address that is used for traffic source from the transparent file, okay, or for managing the session. Clear? So transparent mode is a little bit odd. We have to understand how the working take place. So slowly and slowly we'll understand. Because in routed mode, you are very well aware. Like, if I show you one diagram, you know how it works. See how the routed firewall data flow works. It is very important. You should know how the data flow works. The Cisco ASA appliance receives the packet. Say he is receiving the packet from PC. You can see in the diagram, you have a PC. So the traffic is coming like that. From PC, IP address is 10.0.1.10 routed mode. Gateway is 10.0.1.1. My firewall knows about both these interfaces because you configured it for inside and outside. You give the network also. So Cisco appliance receives the packet and it always verifies if the packet belongs to the existing session. Immediately when he receives, he always check for the session, whether there is an active session or not. Because then if there is an active session, he will immediately forward the packet. Then he don't have to do a lot of things. Okay. But suppose if there is no active session, then ASA appliance check the routing table to determine the egress interface. Now, what is egress interface? Interface to send that packet, to exit that packet, because he receives that packet, so that is called ingress. Ingress means incoming, egress means outgoing. So egress and ingress. So first is ingress. ASA appliance checks the routing table to determine the egress interface to forward the packet. The Cisco ASA appliance check the configured security policies to determine if the packet should be allowed. Now that is very important, because in case of router, until unless there is an access list, he will immediately forward. But if there is an access list, he also has to check, because router also do packet filtering. Router do inter-network communication, router do packet switching, router do packet filtering, router do best path selection. So these are the functions of a router, that is L3 device. Inter-network communication, packet switching, packet filtering. Filtering is the help of ACL. I told you, no, first generation firewall. Routers were first generation firewalls. They also do filtering. That is why there is a saying, always remember, guys, routing is slow than switching. Switching is faster. Routing is always slow. Somebody asks why routing is slow. When he receives the packet, he is going to check the routing table. He will come to know that this is the packet coming from inside interface, which is the subnet is 192.168 something. Then he is going to check for the exit interface. But before going to exit interface, he is going to check for some access list. Okay, access list is permitting or there is no access list, then he will immediately go and check for the NATing, because if the packet is going on internet, he has to do some translation. So you see, there are a lot of stuff being involved in routing mode compared to switching mode. In switching, what happened? A frame is received on the port. After doing FCS, that is frame check sequence is done, immediately the frame is forwarded on another port. Okay, definitely MAC table lookup, but that is also very simple. Now he receives some frame on port number 1, he can find that MAC address on port number 10. If he's not finding it on port number 10, he's going to do what? Broadcast that frame on all the port except the port from where he has received the frame, except the port from where he has received the frame. Simple. So in ASA firewall, remember, this is the sequence. This is the outbound data flow. Outbound. So you see the traffic is coming from PC and it following a lot of things, and then he's sending it on internet. So definitely, if NAT is done on ASA, then Why he has written optional? Because it can be a router here which might do NAT. So optional. So how this is clear, the Cisco ASA appliance receives the packet, always verifies the packet belongs to the existing session. ASA appliance check the routing table to determine the egress interface to forward the packet, that is the exit interface. ASA appliance check the configured security policy to determine if the packet should be allowed, that is the policy access list. If NAT is configured, it is applied according to the egress interface. The ASA appliance record the session. I hope you remember the term state table. So ASA appliance always maintain the state table, that is the session table. So show CONN detail. I always give the command, no? Show CONN detail, that is the connection table, that is the session table, that is the stateful table or state table. Always ASA maintain that session until and unless the session is active. If it is inactive, it will flush the information. This is the behavior, or you can say this is the normal outbound data flow in a firewall. Now let's compare this with transparent firewall, because here we are doing what? Transparent firewall. So in transparent firewall guidelines, what is the important thing that you have to understand? When you enable, see, by default it is disabled, no? Because by default it is in routed mode. You have to be very careful in the lab. If they are asking you to convert your firewall in transparent mode, you have to first convert it, no? Because by default it is in routed mode. So when you enable your firewall in transparent firewall mode, the default mode on the Cisco ASA appliance is definitely routed mode. At least one bridge group must be configured. Now, what is bridge group? You need to club those interfaces, that is inside and outside, into a bridge group. You can make many such bridge group for redundancy and all, but at least minimum one bridge group you have to make it. So all the data interface must anyhow belong to a bridge group. Like like example I'm giving you, we did ether channel bundling. So when we did ether channel bundling, we bundled those physical interface under a port channel 1. You are telling me, no, we did a bundle of two links 3 times. So you will be having 3 port channel: port channel 1, port channel 2, and port channel 3. So same way, when you are making a redundant interface also, if you remember, we created a group for making a redundant interface group. We have to make a group and then we have to add the physical interfaces. Whichever interface is added in the first place will become active. Whichever interface is added in the second round will become the standby. That was there in redundant interface configuration, if you remember. I'm just giving example. Here we are going to follow bridge virtual interface groups. So if you are making your firewall as transparent, you have to be very careful. The firewall will never work until unless you bring all those data interface under a bridge group. Group of interfaces that the Cisco ASA appliance bridge instead of routes controlling communication between multiple segments. Only interfaces that are associated with BVI groups can pass traffic. So this point is very important. Only interfaces that are associated with BVI groups, that is bridge virtual interface group, can pass traffic. It can support up to 250 bridge groups and maximum of 64 interface per bridge group. That means you can make 250 bridge groups, and every bridge group can accompany, or you can say can club 64 interfaces. Too much. It will be cleared when we configure it, no worry. Okay, just to keep in mind that bridge group is important. Now if I tell you about the, okay, this is same, how it works, man, how it forwards the traffic. Now this is again very interesting, because when I told you it is going to work as a transparent firewall, when I told you that it's going to work as a stealth firewall, or when I told you that it's going to work as a concept of transparent bridging, that is bump in wire, stealth firewall, all those terms are there for transparent. Huh? You immediately started, in fact, I also told you the example of switch. Immediately started thinking about the switches, how the switches work. And you know, or you are aware that switches always maintains the MAC table. How they maintain? They start learning the addresses in the beginning, and then they dynamically learn those MAC addresses from the host. So the Cisco ASA appliance adds the source MAC address to the MAC address table. So yes, you're right. Your thinking is correct. My ASA is also working like a switch. Okay. He also maintains a MAC table. Cisco ASA appliance adds the source MAC address to the MAC address table. What is source MAC address? See, initially, who's going to, somebody is going to react, or somebody is going to, you know, somebody is going to react. So if that somebody is like a PC, if we try to send some request, say PC1 want to communicate with PC2, okay. See, if they are in the same subnet, it's okay. But they are trying to access a subnet, no doubt it is connected subnet of ASA, or if they want to go to the gateway, that is 10.1. Now, my firewall will immediately try to learn the MAC address of that particular host, okay, when the packet arrives on a particular interface. Because see, if you see my diagram, definitely 10.2 and 10.3 will immediately ask for 10.1, and they'll try to reach 10.1 through the switch. And if you see in between, ASA is there, or 10.1 will try to reach 10.2 and 10.3, because R1's LAN subnet is 192.168.10. So somebody is trying to reach 10.2 and 10.3, somebody is trying to reach 10.1, because that is their gateway. So in that particular moment, my Cisco ASA appliance will immediately take the MAC address received from a particular interface, when the packet is received on, if the destination MAC address is in the MAC address, if the destination MAC address is in the MAC address table, the ASA forwards. Simple. If the switch is receiving a MAC address from a particular source, sorry, he is receiving a request for a particular destination, and he write down the source MAC address, and if he sees that is the person who is asking for this particular MAC address is in his MAC table, he immediately forwards it. Like port number 1 is requesting for port number 2. a particular MAC address is requesting, immediately forwards. But suppose the thing becomes complicated, or you can say the things changes when there is no MAC address in the MAC table. Because I told you, no, the function is address learning. By default, nobody is going to give them the addresses. It is dynamic way of learning the addresses. So if the destination MAC address is in the MAC address table, the ASA forwards the packet out on an appropriate interface. And if the destination MAC address is not in the MAC address table, the ASA try to discover the MAC address. Now, see, there is this sentence here is not clarifying it how. It's just telling you what. If there is the MAC address is not there in the MAC table, okay, he tried to discover how. You guys must be knowing that switch discovers in a very, interesting fashion. Like how he do, he starts sending a broadcast. Switch will do what? Single broadcast domain. No, I told you in the beginning only, until unless VLAN is created. So switches are going to do what? They are going to start doing. They are going to do what? A broadcast on all the ports except the port from where they have received the MAC address. They are going to broadcast it on all the ports. This is the default behavior of the switches. Up till now, I was just comparing my firewall with switch with firewall with switch, not switch with firewall, but at least firewall with switch, because firewall was working like a switch now, transparent bridging. But now I have to tell you that my firewall is not going to do that like my switch is doing, sending a broadcast. One minute, huh? Just one minute. Okay. So I was just telling you that the working of the switch, one minute. So Cisco ASA appliance adds the source MAC address to the MAC address table when the, but he tried to discover. Now how is he trying to discover? So remember, he is not going to do the broadcast on all the ports like normally the switch do. If a MAC address is not found in the table, the transparent bridge would flood the original packet out on all the interfaces automatically, assuming that the MAC address must be out there somewhere. ASA cannot do that. Very important sentence. The ASA cannot do that simply because it has to maintain security policies that might limit where a packet should go. ASA will attempt to discover a destination MAC address by probing for its existence in one of the following ways. ARP request. When the destination IP address is located on a local subnet that is directly connected to the ASA will send an ARP request to force the destination to answer with its own MAC address in the ARP reply. That means my firewall is trying to send an ARP request. So whenever the destination IP address is located on the local subnet, known subnet, local subnet that is directly connected to the ASA will always send an ARP request to force the destination to answer with its own MAC address in an ARP reply. Once the reply is received, he will write down. So always see when I go on the ASA and show MAC address table, I will always find there are MAC address registered on inside interface and outside interface, because there are these two interfaces which are part of a bridge group interface. A bridge group, I told you, you can go up to 64 interfaces also. You can add more interfaces also, but you have to create a BVI. So see, this is the methodology through which my firewall will try to gain information about a particular MAC address from the same local subnet. That is ARP, because address resolution protocol broadcast can be done with a question. Always remember, normal broadcast is just a plain broadcast being sent on all the ports, but our broadcast is always having a question like who is 192.168.10.1, I'm looking for your MAC address, man. Who is 192.168.10.2, I'm looking for your MAC address. Who is 192.168.10.3, I'm looking. So there is a question with a specific IP address in the ARP request for asking the MAC address of that particular IP address. So it is a, no doubt, it's a ARP broadcast, but it is for a particular user. Okay. Second one is the ping request. When the destination IP address is located on the some distant subnet. Okay. So what he is going to do? How he is going to find out the network which is not from it? Like is trying to find out some network which is not in his reach. Then he is going to send what? A ping request. Okay. When the destination IP address is located on some distance, the ASA will send an ICMP echo request to the destination. Okay. When the destination host or a router responds, the ASA can learn the location of the next hop router address. That can be used to reach the destination. Okay. In earlier boxes, there was some limitation, but not that limitation is gone now because 8.4 version is already old version now. Some of the things that you enjoy in routed mode, you won't be enjoying in transparent mode. Use when only IP packets are to be inspected. Use when non-IP packet must be forwarded. Comparison. Network readdressing is necessary across the ASA. Network readdressing is not necessary. All interface can be used. Only 2 to 4 no, but I told you, this limitation is gone now. You can go up to 64 interface per bridge group. All ASA features are available. So dynamic routing protocol is limited. Dynamic DNS, DSCP relay, multicast, QoS, VPN termination for transit traffic. These are some of the things which are not available. Okay. When you say show firewall, you will see that you are in router mode So in order to make your firewall transparent, you have to make it firewall transparent. What I have, what I am thinking, Mirza and Sivakumar, already there are many people not joining us. So we'll do the practical in the next lecture, that is on Monday. Okay. So we'll end today a theory part here only. Okay. It's better we because only two people have joined. So I feel the practical part is interesting. Okay. So we'll end here only lecture. Good night, Sivakumar, Mirza. Thank you. Bye. Take care.